Hey guys, today is our first day where we're going to be working with Table A. So before you begin this lesson, I need you to go to the course headquarters, go to the AP formula sheet, print that sheet out. If you don't have a printer, that's fine. Just have it open for your access. You do need that today, okay? All right, so let's get going. Suppose a normal model describes the fuel efficiency of cars that are registered in your state. The mean is 24 miles per gallon with a standard deviation of 6 miles per gallon. What we have just learned about the 68, 95, 99.7 rule is we can draw conclusions based off of what that mean and standard deviation are about the population. Okay, so we know we have a normal model. The mean is 24 miles per gallon. So that always goes right smack dab in the center. And what we do then is we measure 3 standard deviations above the mean and then 3 standard deviations below the mean. Okay, so I'm going to be adding 6 each time going this way and subtracting 6 each time going the other way. I'm going to pause the video right now, okay, and I'm going to do that. I want you to do that as well, and when I come back, we'll have that filled in. Okay, so what we know right now in our state of all the cars that are registered, we can draw conclusions about all of these cars. We can say that 68% of cars get between 18 and 30 miles per gallon, right? We can say that 95% get between 12 and 36 miles per gallon. And then we could say 99.7%, well, they get between 6 miles per gallon and 42 miles per gallon. Now, are there people that get over 42 miles per gallon? Sure. The chances, though, are incredibly rare, as well as over here. In fact, remember, when a normal distribution, it really is unusual to be anywhere outside of that a z-score of 2. So that's that second standard deviation, because a z-score is the exact standard deviations you are above or below the mean. Okay. Now, the only issue with the 68, 95, 99.7 rule, it does limit us with the conclusions that we can draw. For example, could we tell what percentage of cars get over 32 miles per gallon? No. So we need a better way. Okay. So that's leading us into Table A. Again, we're going to be using with the same description the whole time, so I'm not going to keep reading it other than the question. What percent of all cars get less than 15 miles per gallon? When you see this, there is a certain step-by-step process that I do want you to follow. So if you're not taking notes yet, in my opinion, it's imperative to do that. And right now, while you're home distant learning, you'll be able to use those notes, okay? Step 1, when we're dealing with this, I want you to draw the curve. Mark your observation, your mean, your standard deviation, and shade. So what does that mean? I'm going to draw the normal curve. Now, I do not expect you on these types of problems, okay, to mark out 3 above and 3 below. Only do that when asked, okay? So we're going to put mu because this is describing the population. Mu is equal to 15. With a standard deviation of 6. And you guys, I lied. I'm sorry. I was looking up this 15 while I was making mu. Please forgive me. Mu is equal to 24. Hopefully that didn't stop anyone in their tracks there. Okay. Okay, so what we just did there is we drew the curve, right? We drew the mean and the standard deviation. Now we need to mark the observation. So what is the observation? The observation is what the question is asking about. So what percent of all cars get less than 15 miles per gallon? This is our observation. So we mark that over here, and you can kind of pick an arbitrary point. Okay, X is equal to 15. I mean, make it somewhat reasonable, but again, I'm not judging that at all. So don't worry about that. Okay, X is equal to 15. So there's our observation. Now, finally, it says shade. Well, how do I know how to shade? I want to see what percent of cars get less than 15 miles per gallon. So that is this area right here. I want all the cars that are less than 15 miles per gallon, this part on the number line. Step 1 complete. Write down any questions that you might have. Step 2. I need to move something. Hold on. Control Z. 1 second. Let me pause it to fix it. Step 2, we need to find the Z-score now for this observation. We want to find exactly how many standard deviation it is below the mean. Okay? So if you remember, I have that acronym ZOMS that we learned before. That means our Z-score is equal to O, our observation, M minus our mean, divided by our standard deviation. I want you to go ahead and pause the video right now, and I want you to calculate that on your own. I will do the same. Okay, I got negative 1.50. Did you? Now, if you didn't, if you got something really big, you didn't type it in your calculator correctly. So make sure you're typing it in your calculator correctly. The next thing we're going to do is we're going to go to table A. So find it now either in the course headquarters or you print it off the formula sheet. And we're going to go outside in. So what is table A? I have it on the next slide. So you should be looking at table A. There are 2 pages of table A. You'll be looking at it and you see negative Z-scores as well as positive Z-scores. What I want you to do now is I want you to mark that this first column here, this is the first 2 digits of the Z-score. Okay? This row right here is the last digit. So we had a Z-score, guys, of negative 1.50. Now there's a reason I added that 0 because I like all of my Z-scores to have to the 100th decimal place. Okay, so round to the 100th, and if there is nothing there, you put a 0. Now, what this Z-score table does is it gives you the percentiles for all of your Z-scores. Now remember, a percentile is measured in terms of less than, okay? Less than. And we want that. We want to know what percentage are less than 15 miles per gallon, which is a Z-score of negative 1.50. So my first 2 digits are negative 1.5. So I'm going to find that now on the row. And I'm going to use my highlighter right now. Negative 1.5 is right here. And now I'm going to go across on the top and I'm going to find the last digit, which is right here, 0. That meant to be an arrow. So 0 is right here. Now what I'm going to do is I'm going to see where these 2 row, or where the row and the column intersect. And that's right there. Hopefully you can see it at 0.0668. Okay. So that table going, oh, and I put outside in for a reason. Let's go back. You can see that we went from the outsides of the table to the inside of the table. That's important to note. Okay. Okay, so now what did we get? We got a proportion. That's a proportion, or another word for it is a p-value. We got a p-val of 0.0668. Let me just double check. I don't want to make a mistake on the video. Yep, we're good. Okay, so that is not a percent right now. That's a proportion. We want to change it because it does ask for the percent. So just move that decimal 2 to the right to give us 6.68%. Okay, so what that means now is 6.68% of cars that are registered in our state get less than 15 miles per gallon in their car. Okay, note that this was a less than. Let's move on. The next one, same scenario, is saying what percent of all cars get between 20 and 30 miles per gallon? So we're going to do it again. We're going to do the same process. We're going to draw the curve. Now, while I'm drawing the curve, a lot of times people will say, do I have to draw the curve? Well, let me tell you this. Let's say you make a little mistake on the AP test. AP readers grade holistically. If you have this all marked really nicely, but you just made a tiny computation error, and you're in between a 3 and a 4, which means on each free response, they grade you out of 4 points. They will say sometimes bump you up to the 4. I call it our insurance policy. Okay, so we're drawing our curve, and sometimes people say, are you sure? Like, how do I know where to mark this? You can try to find the point of inflection. If you don't know what that means, just pick an arbitrary point. It doesn't matter. So we have a mu of 24. We have a standard deviation of 6. So we have marked now the mean, the standard deviation. And now what you'll notice is we actually have 2 observations. We have 20 and we have 30. So we need to mark both observations. So I call it X when we have that, okay, because that's 1 observation. And then 30. And then finally it says shade, okay? So we're wondering what percent of cars get the gas mileage between these 2 values. Okay, step 1 complete. Step 2, z-scores, ZOMs. Okay, we learned about z-scores in another slide. Z is equal to our observation, 20, minus our mean, 24, divided by our standard deviation. Okay, again, we're going to do it over here. Z is equal to 30 minus 24 divided by our standard deviation, 6. Okay, ladies and gentlemen, we're going to find that z-score now. And this one you can do in your head pretty easily. This one gives you negative 1.00 and 1.00. Okay, right? Because 6 divided by 6 and negative 6 divided by 6. Now, we know we have learned, hey, 68% of the population falls within, right? Falls within 1 standard deviation of the mean. Here's the issue. I need to show you how to use the table with these. Because guess what? It might not always be 1.0 or negative 1.0. It might be 1.25 or negative 2.3. So when you have 2 observations, the lesson learned here, 2 observations, you find 2 z-scores, okay? If it falls nicely on there, you can use the 68, 95, 99.7 rule. But if it doesn't, what we need to do now is we need to go to the table, outside in, and we need to go to the table twice. So I'm going to put times 2 because we have 2 z-scores, okay? We have 2 z-scores. So let's go there and let's practice that table again. We have negative 1.00. So here's negative 1.0 and then 0 here. And they are going to intersect at 0.1587. Okay, so let's write that down. The p-value here is 0.1587. Okay, all right, good. Now we're going to do it again over here at 1.0. So I'm going to go to my positive z-scores now, right? Here's my first 2 digits. Here's my last. I have 1.00. I'm going to see where they intersect, and that's right here at 0.8413. Oops, the wrong way. So the p-value here, 0.8413. And let me just double check these because I don't want to be teaching off of a bad calculation, okay? Or bad observation in this case. Okay, we're good. Okay, well now here's the issue. Remember, the p-value is talking about the less than part. So this 0.1587 really represents this part of the curve. And this 0.8413 represents all this. Well, we want the green part, right? We want the green part, okay? So what we want to do now is we want to take the purple part, this big p-value, and we want to subtract it from the blue part to give us the green part. And that's what we do every time you are asked an in-between question, okay? So you want to pay attention when it talks about between. You draw the curve, you mark both, you find two z-scores, and you go to the table outside in twice. Then what you want to do with the p-values for your fourth step is take the big p-value minus the small p-value. So let's pause our video and do that now. What you should have gotten there was 0.6826. Now, which is 68.26%. Now, you're probably wondering, well, why? I thought it was 68% are all within one standard deviation of the mean. I did say in the earlier video about that 68, 95, 99.7 rule, it is an approximation. So here it's a little more exact. And there we go. Write down any questions about the between questions. Let's keep cruising. Okay. Now we're wondering what percent of all cars get more than 40 miles per gallon. Same routine, guys. Okay. I'm going to pause the video right now. I'm going to do this all on my own without walking you through it. I want to see if you can do it as well. So pause and do step 1 for me. Okay. Okay. Does your picture look like this? Do you have the mu? Now, keep in mind, if you're wondering, why is it called mu again? Because it's describing the entire population. And sigma here, because again, the standard deviation that's describing the entire population. We have our observation of 40. And this time we are shading to the right because it's more than. Call that X. Okay, next, what I want you to do is pause the video and find the z-score. I'll do the same and let's see if ours match up. Okay, guys, step 2 for your z-score. Did you get your observation minus your mean divided by your standard deviation to get 2.67? Remember, we went around to the nearest hundredth. Step 3 now I'm going to do with you, okay, because it's a little different. I want to think about that. We do need to go to the table outside in at 2.67. So let's do that now. Whoops, I lost my table, so I'll go back here. 2.6, we're on the positive side. And now we need to go to the last number of 7. Okay, so I'm going to go all the way down. I'm going to keep going down because I'm in the last number of 7. And I'm going to see now where this intersects. And it looks like it intersects right there at 0.9962. Okay, 2.67, 0.9962. Okay, so that's what their p-value is. 0.9962. Now we have an issue, right? The z-score table only tells us the less than portion of the curve. We want the greater than portion. Well, let me tell you this. The area under this entire curve is equal to 1. Okay? So what we need to do, step 4, whenever it's a greater than problem, okay? Whenever it's a greater than problem, we need to now do 1 minus what we got from that p-value. And when I get that, I get 0.0038, okay? And that's the proportion. And if you want to keep it as a proportion rather than a percent, I'm fine with that. That's not a big deal to me, okay? So what did I do there? I'm going to do 1 minus the p-value that you got, that proportion that you got from going to the table. All right, what we have learned, we mark our observation, our mu, our standard deviation. We get our z-score. We go to the table outside in, and because it's a greater than problem, we need to do 1 minus. I'm going to end right here, okay? This is part 1 of using the table. You still need to do part 2 of using the table, but I think it's time for a little break.